Hi, good day everyone. Assalamualaikum. So today we are going to continue with lecture 4 of 5 for matrices. So we are going to focus to the last subtopic of matrices and system of linear equation, which is the system of linear equation with three variables. Okay, so the learning outcome for this lesson, at the end of the lesson, students should be able to write a system of linear equation. You have to know to write a system of linear equation. Okay, in the form of ax equal to b. This is in matrix form. So matrix A multiplied with matrix X is equal to matrix B. And then you have to know how to solve the unique solution of AX equal to B using the first method, which is the inverse method. So we should know to solve for this system by using the first method, which is inverse matrix. So on the next lecture, we are going to focus on the second method. System of linear equation. So let us discuss one by one the meaning of the words in this statement. So what is system? It's like a system, bahasa Melayu dia system lah. Okay. So awak faham apa maksud sistem kan? And linear equation. So it's a group of linear equation lah. So system of linear equation ni dia adalah satu gagasan daripada linear equation semuanya. Okay. Persamaan linear. Okay. So kita ada banyaklah persamaan linear ni. So sebenarnya you dah pernah belajar. Kenapa? Dekat zaman sekolah dulu, you belajar dua equation dengan dua unknown, dua nilai yang awak tak tahu, dua variable. So you boleh selesaikan dia. So kalau dalam system of linear equation samalah. Cuma kita akan pergi advance sikit. Why advance? Because up to your level, we should know to solve for the not only two variables but three variables. Okay? So to solve by using three variables, kalau you nak guna simultaneous, it will be a bit tedious lah. Banyak step. That's why we introduce this matrix. Matrix we make it easier to solve the system of linear equation for more than two variables. Okay? Actually, if you go higher in university, we will solve for 4 by 4 or 100 also we can. But not directly by using your hand working lah. We build a system by using computer programming. That's why in university it will be higher lah. Takkan nak buat 3 by 3 je kan? Okay. So consider the system of linear equations with three unknowns. Now we have three unknown. Usually we use x, y, z, right? But here we use x1, x2, x3. Okay, why x? Because it's the same thing lah. Bukan same thing, in the same group. They are x. So that's why we use x1, x2, x3. And then every x has their coefficient and it will be equal to a constant. Okay? So this is what we call as the linear because the x only to power of 1. Right? But and we have three unknowns in every equation. So A11 is the coefficient of x1, A12 is coefficient of x2, A13 is coefficient of x3 equal to a constant B1. The same for the second equation. All these A will be different. Okay, so they represent the A because later the linear system above can be transformed into matrix equation as below. A matrix A multiply a matrix X equal to matrix B. Why? Because we know when we multiply between two matrices, so we'll get this first row multiply this first column, right? So, this first row multiply with this first column, we get first element on the right side, because this is a 3 by 3 and this is a 3 by 1. So your result should be a 3 by 1 matrix, right? So if we do the multiplication between these two matrix, what do we get is A11 multiply X1, A12 multiply X2, A13 multiply X3, and adding up all, we get equal to B1, which is equivalent to the first equation. The same for the second row and first column. A21 multiplied by X1, A22 multiplied by X2 plus A23 multiplied by X3 will be equal to B2. A31 multiplied by X1 plus A32 plus multiplied by X2 plus A33 multiplied by X3 equal to B3, which is equal to the third equation. Okay, so that's why we can transform the system of linear equation in a matrix form. So this matrix AX is the coefficient matrix A, and variable matrix X, the one that we want to find, and the constant matrix B. Thus, the system of linear equation can be written as AX equal to B. Let's do some example. So write the system of linear equation below in the form of AX equal to B. So it will be really easy. You should know how to transform this system of linear equation into matrix form. Okay, AX equal to B is in the matrix form. So let's say we do for the question A. So we only have two variables X and Y. So we know directly our variables matrix X is equal to XY. But now we need to find what is the coefficient. So depending on the variable, just take the coefficient for each of these in the form of 2 by 2 matrix lah, because this is 2 by 2 matrix. So this X has a coefficient of 1, right? So we have 1 and 2 for position A12 and then 2, 4. So the matrix coefficient matrix A is equal to 1, 2, 2, 4. And then directly multiply with the variable matrix, which is X and Y. And what is the constant? The constant is every constant on the right side. Okay, so we have 1 and 3. Understand or not? Simple, right? So let's do for question B. So determine the coefficient for each of the variable. So make sure you line up the variable consistently. So if we start with X, follow with Y, and end with Z, so every equation should do like this. So everything should start with X, Y, Z, X, Y, Z, X, Y, Z. Okay, so we have done. And then make sure the constant is always on the right side of the equation. So we have constant on the right side already. So we can now separate the coefficient and the variable matrix. So what is the coefficient for the first row? Will be here is 1, 1 and negative 1. Okay, and then for the second equation, 2, don't forget the sign, negative 3 and 1, because it's supposed to be adding up. So if we have minus, then we have to take it as the sign. And then the third row is 2, 1, 2. And then the variable matrix is X, Y, Z lah. And the last one is the constant matrix, which is equal to 0, 1, 7. Really easy. So let's do example. Okay, now for this type of question, usually they will give you a situation where we need to interpret on our own. So usually this interpretation will take a longer time rather than to write down the solving. Okay, so you have to understand and recognize what is the X, Y, Z that we want to find, and then what is the coefficient matrix, or what is the equation that involved in this system. Okay, so let's read example 2. In a supermarket, There were 3 promotion packages A, B and C which offer shirts, long trousers and neckties. The number of each item and the promotion price for each package is given in the following table. Okay, so for package A, so we have 3 number of shirt, 2 trousers, 2 neckties with a promotional price of 256. For package B, we have 4 shirts, 1 trousers, 2 neckties with a promotional price of 218. And for the package C, we have 2 shirts, 1 trousers, 3 neckties with a 173 promotional price. So, by using X, Y, Z respectively to represent the price of a shirt, a pair of trousers and a necktie. So, X is representing the price of a shirt, Y representing the price of a trousers, Z is representing the price of a necktie. Write down the system of linear equation and metric equation to represent the information above. So, if we notice from the table previously, okay, so we have a package A where they put 3 shirts, 2 trousers and 2 neckties, right? 3 shirts, 2 trousers and 2 necktie. Okay, with a price of something, I forgot the price, but we don't know what is the price of each of the shirt. So, if we want to know what is the price of the shirt, we know already the total price of this package A, right? So, to find out what is the price, we can represent the price of the shirt as X, the price of the trousers with Y, the price of necktie with Z. So, the total, the 3 of the price of the shirt plus with the 2 trousers multiplied with the price of the trousers plus with the 2 of neckties multiplied with the price of a necktie will equal to the total price. So now, what are the system of linear equation? Because we are representing the S, T and N with X, Y, Z. So we will get, okay, this is, we can represent the number of shirt, number of trousers, number of neckties. No, the X is the price, okay? X, Y, Z is the price for each of the shirt, trousers and neckties, okay? So, the system of linear equation is that 3 shirts multiplied with the price plus with 2 trousers with the price of the trousers plus with the 2 neckties multiplied with its price will have 256 as the total. Okay, so we can have 3x plus 2y plus 2z equal to 256. So 4 shirts multiplied with its price plus 1 trousers multiplied with its price plus 2 neckties multiplied with its price will have a total of 218. The same for package C. 2x plus y plus 3z is equal to 173. Okay, so we have this system of linear equation with 3 variables x, y, z. Now we want to find the price of each of the items. So we have to solve this system of linear equations. Okay, if we want to solve this system of linear equation, means that we want to find the value of x, the price of the shirt, value of y, which is the price for the trousers, and value of z, which is the price of the necktie. Okay, so how to solve? We can use the simultaneous equation, but it will be tedious. So why not we apply the matrices method? Okay. Okay, so now the question only asks you to find the system of linear equation. So we solve already. Now we want to write down in a matrix form. So separate the coefficient matrix, the variable matrix and the constant matrix. So directly we take the coefficient of each of the variable. We have 3, 2, 2 because we already arrange it in x, y, z form. Okay, so it will be 3, 2, 2, 4, 1, 2, 2, 1, 3. And multiply with the variable matrix x, y, z will be equal to a constant matrix of 2, 5, 6, 2, 1, 8, 1, 7, 3. Okay. So let's see example 3. So Puan Lili wants to buy 3 different flavors of ice cream for children. Okay, for the first child, she buy ice cream which costs 2 ringgit for a scoop strawberry, 3 ringgit for a scoop of vanilla, and 4 ringgit for a scoop of chocolate. For the second child, she buys ice cream which costs 4 ringgit, 3 ringgit, and 1 ringgit for a scoop of strawberry, vanilla, chocolate respectively. Meanwhile, for the third child, the cost is RM 1 ringgit, 2 ringgit, 4 ringgit for a scoop of strawberry, vanilla, chocolate respectively. She buy X scoop of strawberry ice cream, Y scoop of strawberry ice cream, and Z scoop of chocolate ice cream for each of child. She spent 34 ringgit on the first child, 28 ringgit on the second child, and 27 ringgit for the third child. Write the system of linear equation for the above problem and the matrix equation. So we want to find the system of linear equation, also the matrix equation. Okay, now what is x, y, z? X, y, z is the number of scoop strawberries ice cream. Okay, y for vanilla ice cream, z is chocolate ice cream. So for each of the child, the price is different. So we can, for the first child, we draw it in the table because it will be easier to recognize. So we have 2 ringgit, 3 ringgit, and 4 ringgit respectively, with the total cost with 34. And then for the second child is 4 ringgit, 3 ringgit, and 1 ringgit, which cost of 28. And then for the third one is 1, 2, 4, and then with total cost of 27. Now, actually directly we can write down the system of linear equation because we have a total here. So if we have a total here, this total will be the constant metric, right? So we have equation from the left side to the right side. Okay, if we have the total here, then the equation will go this side, this line. Okay, so you can recognize it, lah. Okay, now write down in the system of linear equation, we have 2x plus 3y plus 4z equal to 34, which is for the first child. This is the first child. For the second child is 4x plus 3y plus z equal to 28. And the third child is 1x plus 2y plus 4z equal to 27 cost. Okay, now in the matrix equation, we can separate the coefficient and the variable matrix, which is, don't forget to arrange in the consistent form x, y, z. So we have 2, 3, 4, 4, 3, 1, and 1, 2, 4. Multiply with the variable x, y, z equal to a constant of cost, which is 34, 28, and 27. Okay, now we know how to write down the matrix form. Now, if we have the matrix form already, now we can solve it by finding the matrix X. Okay, now to solve the matrix X, we have two methods. The first method is to use the inverse matrix. Okay, this inverse matrix, you already learned it in the third lecture, which is we can use two methods. The first one is to use the what? The adjoint method. Okay, adjoint method, where you need to find determinant of A and then multiply with the adjoint of matrix A. And the second method is use the properties AB equal to KI. If we have the multiplication between AB equal to KI. Okay? Okay. Now, if A is an n by n square matrix that has an inverse of A inverse, X is a variable matrix and B is a known matrix both in n rows, then the solution of matrix equation X is equal to B is given by X equal to A inverse B. So now we want to find X only, so we want to let X as the subject. We cannot directly multiply A or bring A to the right side. No, we have to eliminate this A. That's why we need to multiply A inverse from the left side, because matrix A in the left side of the equation. So if we multiply from the left side, on the right side also we need to multiply from the left. That's why we have A inverse multiplied by AX equal to A inverse multiplied by B. It must be from the left because it's not commutative. And then, so A inverse multiplied by A is I. Then we have X equal to A inverse B. So IX is equal to X itself. Okay, that's why we can solve it by finding the A inverse of the system. So, what is A inverse? Means that we have to find the inverse of the coefficient matrix. So, let's say example 4. Given A equal to matrix 1, 2, 0, 3, 2, 1, 2, form 1, and matrix B is a 3 by 3 matrix of 2, 2, negative 2, 1, negative 1, 1, negative 8, 0, 4. Find AB and hence determine A inverse. So now we want to multiply A and B, and then we want to find the A inverse. And for question B, okay, so this is a situation question. So let's read together. A hawker sells 3 types of cakes, namely cheese, chocolate, and strawberry cakes. The price of each type of cake is fixed. Amy pays 5 ringgit for 1 cheesecake and 2 chocolate cakes. So Amy pays a total of 5 ringgit for 1 cheesecake and 2 chocolate cakes. Nurul pays 10 ringgit for 3 cheesecake, 2 chocolate cake and 1 strawberry cake. And Chong pays 13 ringgit for 2 cheesecake, 4 chocolate cakes and 1 strawberry cake. By denoting X, Y, and Z as the price of each cheese, chocolate, and strawberry cake respectively, form a system of linear equation based on the above information. Write the system of linear equation in the form of matrix equation and hence solve the price of each type of cake. Now, what the question asks you is to write the system of linear equation in the form of matrix equation. And first question is form a system linear equation first, and then solve the price. So what we want to find is to find the price, which is to solve the X, Y, Z lah. Okay, so let's do question A first. Find AB and hence determine A inverse. So A multiplied by B, so matrix A multiplied with matrix B. So directly we use excuse me, the method we know for multiplication. So we have to separate into row for the left matrix, separate into column on the right matrix, and then we will have the results. So after you multiply, what do we get is AB is equal to matrix of 4, 0, 0, 0, 4, 0, 0, 0, 4. This is the final answer for matrix B. Hence, determine A inverse. Means that by using the result from this AB, we want to find A inverse. So what we can do, AB is equal to, actually it's a factorize of 4 multiplied by identity matrix. So if AB is equal to I, we can find A inverse by using properties method, which is AB equal to Ki. So A inverse equal to 1 over K of B. So what is our K? Our K is 4. Means that A inverse is 1 over 4 of matrix B. So what is matrix B? This is the matrix B. So multiply 1 over 4 with the elements of matrix B. So we have the answer as 1 over 2, 1 over 2, 1 negative 1 over 2, 1 over 4, negative 1 over 4, 1 over 4, negative 2, 0, 1. Okay, so this is our inverse matrix. So let's move on with question B. So let's from the question it says that XYZ is representing the price of the cakes. So X, if we have for Amy, we have 1 slice cheesecake and 2 slices of chocolate cake without strawberry cake. The total price is 5 ringgit, right? So strawberry cake will be 0 here. And then for the next one, 3 cheesecake, 2 chocolate cake and 1 strawberry cake. The total price is 10 ringgit. And the third one is 2 cheesecake with 4 chocolate cake and 1 strawberry cake with total price of 13 ringgit. So now to find this total price, we only know if we know the price of the cake, the slice of the cake, the slice of the every cake. So 1 cheesecake multiplied with the price plus with 2 chocolate cake multiplied with the price, and we have a total 5 ringgit. That's why we can write down the equation of the system of linear equation is equal to x plus 2y. Actually here we will have plus 0z because it's 0, so we don't have to write lah. So we directly have x plus 2y equal to 5, 3x plus 2y plus z equal to 10, and 2x plus 4y plus z equal to 13. Okay, to write down in the matrix form. So what is the coefficient of the variables? So remember, for the first equation for z, the coefficient is equal to 0. That's why for matrix A we have 1, 2, 0, and 3, 2, 1, 2, 4, 1. And the variable is x, y, z equal to a constant of 5, 10, 13. Now we want to solve for x, y, z. We notice that actually this matrix A is the same A from the previous part A, right? So to solve for x, y, z, we actually has to, let's say we represent it as A, x equal to C, this matrix C, because we have B in part A, right? So we use another representation, matrix C. So this matrix A, okay, because matrix B is already defined in the question. Okay, so this matrix A actually from the previous part, the same matrix from the part A. So from part A also we already has A inverse. Now to find x, it's actually equal to A inverse multiplied by C, right? So this A inverse we found it already from the previous part, so it's a result from A, so we just use it back. So we don't have to find the inverse, okay, because we have the result already, and multiply with matrix C. So we just have to do the multiplication between matrix A inverse with matrix C. So use do the calculation for the multiplication. Divide into row, multiply with the column. So we have the result is 1/2 multiplied by 5, 1/2 multiplied by 10, negative 1/2 multiplied by 13. We have 1. And then 1/4 multiplied by 5 minus 1/4 multiplied by 10 plus 1/4 multiplied by 13. We have 2. And the last one, negative 2 multiplied by 5 plus 1 multiplied by 13. So we have 3. So the price for each of the slice of the cake is 1 ringgit, 2 ringgit, and 3 ringgit. So we have to do the conclusion because it's not a direct question but it's a situation question. Therefore, the price of the cheesecake equal to RM1, chocolate cake equal to RM2, strawberry cake equal to RM3. Okay? Okay. Okay, so let's do example 5. Okay, a company produced 3 grades of mangoes, X, Y, and Z. So kalau pasal mangoes, usually we will reminded by harum manis, right? Okay, so let's read the information given. The total profit from 2 kilograms of grade X, 4 kilogram grade Y, and 5 kilogram grade Z mangoes is 34 ringgit. So from here, okay, so we have a total profit from combination between grade X, Y, and Z. The profit from 3 kg grade Z is equal to profit from 1 kg grade X mango. You don't have total profit here. Okay. The next sentence, the total profit from 2 kg Y and 3 kg Z mangoes is RM12. Okay, so we have a total profit here. Two total profits. Let X be the profit per kilogram for grade X and Y be the profit per kilogram for grade Y and Z be the profit per kilogram for grade Z. Okay, so means that X is the variable and representing the profit for 1 kilogram of grade X. So Y for grade Y, Z is for grade Z. Now, if we read the question again, we only have two sentences that talking about total profit. Okay, so the total profit for the first sentence, 2 kg of X. So 2 kg multiplied by X ringgit for per kilogram for grade X, and then 4 kg multiply Y ringgit for grade Y profit, and 5 kg of grade Z multiplied with the price for grade Z per kilogram is the total profit is equal to 34. Okay, so that's the first equation we found, and then we also know this total profit from 2 kg Y, so 2Y plus 3 kg Z is equal to 12. So where is another equation we should know? Okay, they said, okay, here in the middle, the profit from 3 kg of Z equal to profit from 1 kilogram of X. So 3 kg of Z, the profit equal to 1 kilogram of X. Means that 3 multiplied with the profit for grade Z is equal to 1 kilogram of profit of grade X. So we have this type of equation. Okay, so this type equation is not the normal equation we have. This is another method to write down the equation, just a equality between two grades. Okay, so we can use this also, but what you need to do is to write down in the same form of the first and third equation. Okay, so from the now we have the three equation. We just have to write down in the correct form. So let's continue. So the question asks you to obtain a system of linear equation to represent the given information. So we have it already. And then write down the system in A as a metric equation. Okay. And then find the inverse of matrix A. And lastly, use inverse metric to solve the system of linear equation. Hence, state the profit per kilogram for each grade. Means that we have to do the conclusion lah. So we know X, Y, Z representing the profit for each of the grade. Now we have the system of linear. We found it already earlier. So 2x plus 4y plus 5z equal to 34. For the second one, negative x plus 3z. It's supposed to be 3z equal to x, right? But because we need to write down in this form, because the constant should be on the right side. Other than that, we should put it on the left side. That's why we have negative x plus 3z. Please write in this form. Okay, because later we will change into matrix form. It will be easier for you lah. And the last one is 2y plus 3z equal to 12. So now for the next question, we need to find in the form of metric equation, right? So what is the coefficient? So for the first line, we have it perfectly, which is 2, 4, 5. So it's easy for the first row. How about the second row? We don't have y, so it will be negative 1, 0, 3. And the last one, we don't have x. So the x should be, coefficient of x will be 0. So 0, 2, 3. And the variable will be x, y, z equal to the constant on the right side, which is 34, 0, and 12. So now we found the question B already. For question C, Find the inverse of matrix A. So what is matrix A? So this is our matrix A. We want to find the inverse. So how many methods we can find the inverse? There are two methods, right? Adjoint method and AB equal to KI method. But we don't know, we don't have any information to get the AB equal to KI method. So what we need to do is to apply the adjoint method. So to apply the adjoint method, the formula is 1 over determinant adjoint A. So we have to find the determinant, we have to find the adjoint. So what we need to do first of all, is to find the adjoint first. Because to find the adjoint, we have to find the cofactor. And then the cofactor, we can use it to find the determinant. Okay, so first step, we have to find the adjoint, means that we have to find the minor first. So to find the minor, because we need to find the cofactor, right? So to find the cofactor or minor, so the minor, first of all, we find out what is the minor. So we need to delete according to the position. So for the first row, first column, delete first row, delete first column. So we have 0, 3, 2, 3, right? 0, 3, 2, 3. So we have 3, 0, minus 6, so negative 6. And then for the second position, we have, okay, so they calculate it for you already. So we have negative 1, 3, 0, 3. So negative 3. And then the next one is negative 1, 0, 0, 2. So it's negative 2. And continue lah. So 4, 5, 2, 3. So 12 minus 10 is 2. And then 2, 5, 0, 3. So 6. And then 2, 4, 0, 2 is 4. And continue with row 3. 4, 3, 0, 5, 12. And then 2, 5, negative 1, 3 is 11. And then the last one, 2, 4, negative 1, 0 is 4. Okay, so we have the minor, means that we can find the cofactor by putting the sign on each position respectively. So we have plus, minus, plus, minus, plus, minus, right? So directly we get negative 6, 3, negative 2, negative 2, 6, negative 4, 12, negative 11, 4. Now, we have the cofactor, means that we can find the adjoint, we can find the determinant. Now, first we find the determinant. So, what is determinant? It's A11, C11 plus A12, C12 plus A13, C13 if we choose the first row. So, what is A11? It's 2 multiplied by its cofactor, negative 6. Okay, 2, negative 6 plus 4 multiplied by 3 plus 5 multiplied by negative 2. You can use any row or any column. It will be the same answer. So, jawapan dia kat sini. So, we get negative 12 plus 12, 0. So, negative 10. Okay. So, directly we can find what is our inverse. So what is our inverse? It's a 1 over determinant multiplied with cofactor transpose, which is cofactor transpose is the adjoint. So now cofactor we have, determinant we have. So find the adjoint by transposing the cofactor. We get negative 1 over 10 of negative 6, negative 2, 12, 3, 6, negative 11, negative 2, negative 4, 4. And then multiply with the constant negative 1 over 10. So we have the final answer of 3 over 5, 1 over 5, negative 6 over 5, negative 3 over 10, negative 3 over 5, 11 over 10, 1 over 5, 2 over 5, negative 2 over 5. Okay, so we finished question C. Continue with question D. Use the inverse matrix to solve the system of linear equation. Okay, now to solve the matrix, we have Ax equal to B. So we want to solve the matrix X. So by applying multiplication between matrix, we know that Ax is equal to A inverse B. Where A inverse, we know already from question C. So what A inverse? This is the matrix of A inverse multiplied with matrix B, which is 34, 0, 12. So do the multiplication. We will have the answer equal to 632. What is 632? 6 is x. X equal to 6, y equal to 3, z equal to 2. What is x, y, z representing? It's representing the profit for each of the grade of mangoes. So, therefore, profit per kilogram for grade X is equal to 6 ringgit, grade Y equal to 3 ringgit, and grade Z equal to 2 ringgit. So this value X, Y, Z will satisfy our previous system of linear equation. It should satisfy because it's coming from the equations. Let's say we check for the second equation, which is 3Z is equal to X. 1 profit of X, 1 kilo profit of X equal to 3 kilo profit of Z. What is Z? Z is 2. So 3 multiplied by 2. What is profit of X? 6 ringgit. So it's true. It should satisfy the system of linear equation. Okay? So that's why we do these steps. So finish example 4. Example 5. Yes, we finished discussing example 5 already. So this is the normal, the usual type of question come up in exam. But because this chapter is not in examination, so you have to be prepared for the individual assignment lah. Individual assignment in the beginning of September. Example 6. Okay. So given the matrix B and matrix B inverse, so we have these two matrices B and B inverse. Solve matrix X such that B squared plus X is equal to a new matrix, 3 by 3 matrix. Okay, so how to solve for this one if we only know for B inverse and B, matrix B and B inverse. Okay, so if we don't want to find the B squared or B multiplied by B, let's rearrange the equation first so that X will be the subject. Okay, now we can, after that we can do the operation, solve the equation. Okay, so let's say we represent the right side matrix equal to C. Okay, so we have B squared plus BX equal to C. Now we want to let X as the subject, so we have to minus the B squared. Right? Bring B squared to the right side, or we subtract B squared on each side. So we have BX equal to C minus B squared. And then to let X as the subject, we have to eliminate this B. So how to eliminate this B? By multiplying the B with its inverse so that it will be an identity. So X will be alone on the left side. So we need to multiply B inverse from the left side on each side. Understand? Multiply from the left on each side. So it should be this statement is not accurate. Note that matrix B is on the right hand side of matrix X. No, it's on the left hand side of matrix X. So we should multiply from the left hand side each term. So we need to multiply B inverse with BX and B inverse with C minus B square. After that, you on the left side, directly B inverse B X equal to, this one you have to expand. This one is the properties of addition and subtraction. So it's okay. You just expand as usual. Properties of multiplication between matrices. So B inverse multiplied by matrix C minus with B inverse multiplied with matrix B squared. So on the left side, B inverse B is equal to I And then the right side also, this is actually B inverse multiplied by B multiplied by B. This B inverse multiplied by B is equal to I. That's why on the right side we have B inverse multiplied by C minus I multiplied by B. Okay, so this is I. So we have X equal to B inverse C minus B. So now to find X, we only have to substitute the matrix B inverse and B into the equation. So what is B inverse? We have it already in the questions. And matrix C also, we have it in the question. Also for matrix B. Now we have to do only multiplication between B inverse and C. Okay? So what do we have for the multiplication? 18 minus 10, 8 minus 8, 0. And so on. And then we have 12 minus 8 is 4, minus 3 is 1. 12 minus 6 minus 5 is 1. And then continue. Negative 24 plus 20, negative 4. And then plus 8 is 4. Okay. Negative 16 plus 16, 0 plus 3, 3. And then negative 16 plus 12 is 4 plus 5 is negative 16 plus 12 is negative 4 plus 5 is 1. And the last one, negative 1 multiplied by negative 1 plus multiplied by 6. Negative 6 plus 8 is 2. Negative 1 plus multiplied by 4. Negative 4 plus 3 is negative 1. Negative 1 multiplied by 4 is negative 4 plus 5 is 1. Okay, now we have the multiplication between B inverse and C, and we have to subtract with matrix B. So do the subtraction. So we have negative 2, 0, 0, 1, 1, 0, and 0, negative 2, and negative 1. So this is the matrix X. Easy, right? So after all, what we need to do is to let the X as a subject as usual, the same in calculus. So we let X by using the properties of the multiplication, subtraction, addition. Okay, now then we just substitute all the matrix we need to solve for the X. That's all. So we finish for the lecture 4. For lecture 5, we are going to discuss about system of linear equation again, but to solve it by using a different method, a new method for you guys. Okay, so stay tuned for the next lecture on later. I will I will post it in the group channel Telegram. Okay, so thank you class.